Hi, everybody. Welcome to Tuesdays. Sorry about the schedule mix-up. I couldn't make it into school, and I had another appointment, so we have to do it like this. Sorry you can't actually see me, but I am here. So um, yeah, hopefully you can hear me. Hopefully you see me, or you don't see me, but hopefully you can see my screen and the stuff that I'm writing. If you can't, please let me know. I am monitoring both the chat and Teams, and there's probably a little bit of a delay, but let me know if you have a question or something, and I'll get to it as soon as I can. All right, so today we're going to talk about balancing equations, which for the class that was yesterday, I know you had some questions about this because it was part of the lab, even though we hadn't really talked about it yet. So we're going to talk about it now. I've got the notes today in the class notebook in the content library section. So if you want to follow along, you can do that, or if you want to refer to whatever I write later, they're all there. It'll all be saved there. Okay, so what you see on the screen right now is the activity that I posted up on Teams as something you can work through to meet this objective for this module. And it's just a way of kind of like slowly taking you through the concept of balancing chemical equations. So let's first distinguish the difference between a chemical equation and a chemical reaction. The reaction is the thing that actually happens, like the thing you do in lab. And the equation is the thing that we write that describes that. And so when you see things like these things here, we would say those are chemical equations. All right. So how do we deal with this idea of balancing chemical equations? I also have on here, we can look at it in a second, the lab, and we'll go into that too. So first of all, let's just look at what these things mean and try to make some meaning out of them. So I'm going to actually copy this over so I can draw on it and stuff. So what we see here is H2 plus O2, those are both gases, and they're becoming water, which is also a gas in this case. So H2 and O2 becoming water. All right. And it looks like my video is maybe a little behind here or something. Like it's not synced up with my audio quite right. Let me see if I can do something about that. Just a second. I'm in a little bit different setup here, so I wonder if that's causing some kind of problems here. It seems like everything is moving too slowly. Sorry. Bear with me for a second. If I can't get it to work in a couple minutes here, we'll just have to put this up until tomorrow. Yeah, I don't know why that's moving so slowly. Maybe it's just the way it looks to me. All right, I'll continue, and if it doesn't work out, we'll just redo this. But somebody let me know if something weird is going on. It doesn't seem to be coming through properly for you. All right, so we've got H2 and O2 become H2O. So this is describing a chemical reaction, the reaction between hydrogen gas and oxygen gas to become water vapor. So the problem with a chemical equation, or the problem with this particular chemical equation, as you might see, is that it doesn't actually account for all the atoms. So one thing you'll notice from the lab, if you did it yesterday or if you're getting ready to do it tomorrow, is that you see the space filling models. I'm not going to try to draw those here, but I will just draw out some representations of these molecules. Don't worry too much about how I'm drawing them at this point. We'll get into that next week. But basically, two hydrogen atoms connecting together, two oxygen atoms connected together, and then a water molecule as the result. And so what you might see, hopefully, is that we're missing an atom. So we've got two hydrogen atoms on the left, and two on the right, but two oxygen atoms on the left and only one on the right. And that's a problem because we can't just have atoms disappearing. So there's got to be something else going on here. There isn't just an extra oxygen atom, or we would know that it's there, and it's not. So it's not that. It's not that we've got our formula wrong. We know, let's say we've got some analytical equipment and we know that we've made water. So we know that part's right. So what's going on? Well, what's going on is that this is not the correct ratio that these things actually react in. So what that means is the way that we've drawn this equation is showing one molecule of H2 reacting with one molecule of O2, making one molecule of H2O. And that's the wrong ratio, and that's what's giving the problems. So consider, for example, if we instead react two hydrogens with one oxygen, one O2 molecule, and then make two waters, now we don't have that problem anymore. We have everything properly accounted for. The way we express that in a chemical equation is by putting a big number out front. So 2 here and 2 here represent that there are two of each of those atoms, or of each of those molecules. So having two of each of those molecules means that now we've accounted for the fact that these molecules actually react in a 2-to-1 ratio, not a 1-to-1 ratio. And so that's the difference. All right, so that's what we call balancing equation. So that's now a balanced equation. The reason we do that is because we can't change these little numbers that we call subscript for underneath subscript, because those would change the actual identity of the compound. So if you had H2O versus H2O2, well, H2O2 is hydrogen peroxide. That's clearly a different thing than water. And so we can't just change those subscripts. We can only change um, the coefficients, the things that are next to it. So we're going to use both of those terms to talk about when we talk about balancing equations. All right, so going back to this thing then. Okay, so the one that's written here actually is balanced, the one that's written in the document below. Again, it looks like it's not scrolling down when I'm scrolling down, so I'm not sure what is happening there. There it goes. That's really weird. Why is there a delay there? All right, anyway. So this asks you to use some of the information that's shown here to answer some of these questions. And you know, these questions will seem really easy at first, and then they build up to the knowledge that you want to have. So it's good to actually work through them in order and to take the questions seriously, but don't think too hard about them. So for example, this first part describes some things. Atoms are neither created nor destroyed when chemical reactions occur. Two balanced chemical reactions or equations are given below. In a chemical reaction equation, reactant atoms are shown on the left side of the arrow. Product atoms are shown on the right. So then the question says, considering the reaction, what are the reactants and what are the products? Well, if you were paying attention to that previous paragraph, that should be pretty simple because it's telling you reactant atoms are shown on the left and product atoms are shown on the right. So you should be able to then write those things down for reaction number one. And that's all they want you to do there. And then you'll start to kind of build up that knowledge a little bit more. So work through this, and then there's a few practice problems to try here, but there's not a whole lot. So we definitely want more than that. And then I should have crossed these out, but you can skip 2 and 3 because we haven't talked about moles yet. Sorry, we've got to wait for this thing to catch up again. Yeah, something weird is definitely happening here. Okay. Well, we might have to redo this on Wednesday. But that's most of what I wanted to say about chemical equations. The only last thing is, here, there's this website, and I'll put it in the chat, that is a good way of, oh no, I hit a button. Let me try that again. I'll put it in the YouTube chat here. It's a good way of practicing these because it gives you the answers right away, and it allows you to also see how these things work in terms of like what does it mean to balance the equations? What do the pictures look like? So you can see here in this first example, which I broke again, and this thing is not going well today. Let's try this again. All right, well, that's not working either. Okay, well, we will try this again on Wednesday. I'm really sorry this didn't work out, but hopefully tomorrow I will be back in my regular setup, and so things should be okay. So if this didn't make any sense, then we'll try again tomorrow. Sorry, everybody.